And welcome to our video on finding the equation of a straight line. Now the general equation of a straight line is y equals mx plus c, where m is the gradient, which we can find using one of the three gradient equations we've been using in the past. I've got one of them here, y2 minus y1 over x2 minus x1, and c is the y-intercept. So I'll just label those here for you. The y-intercept is on the y-axis. Whoops, that's a funny looking arrow. And the gradient is how steep the line is. This value over here would be the x-intercept, but we don't use it in the general formula. An alternative equation that we can use when we're trying to find the equation of a given straight line is y minus y1 equals mx minus x1. What I want to point out to you here is the y, nope, I won't cross it out, I will highlight it. The y and the x here don't have a 1 or a 2 next to them. So whenever we use this formula, the y and the x stay as a y and an x. The m and the y1 and the x1 we substitute values in. So don't get confused and think you need to substitute the x and the y, only substitute the three ones that I haven't highlighted here. Both of these equations allow us to determine the equation of a straight line given either a gradient and a coordinate, and I recommend you use this equation if you have one coordinate and you know the gradient. Or if you have two coordinate points, you will need to first of all find the gradient using this equation, and then you can use this equation. I have two examples here for you to have a go at. Pause the video now to have a go at these. Okay, hopefully you've had a go at these. Just going back to the equation, there we go. Find the equation of the straight line with gradient 3 and passing through this coordinate. So we have, I might highlight these as well, a gradient and a coordinate, or two coordinate points. We have here a gradient and one coordinate point. So it's number 1, and we can use this equation here. First step is to write the equation out. Y minus y1 is mx minus x1. Second step is substitute your values. This is going to be y, this is going to be x. Y minus y1 is negative 2. M is 3. X minus 3. And we get y plus 2 equals 3x minus 9. Y equals 3x minus 9 minus 2 minus 11. And that's your final answer. You could put a box around that. Part 2, find the equation of the line passing through these two coordinates. If we've got two coordinate points, we need to first use this equation to find the gradient. M equals y2 minus y1 over x2 minus x1 equals, okay, need to label these so I don't get confused, x1, y1, x2, y2. y2, negative 1 minus 4 over 1 minus negative 1. Negative 1 take 4 is negative 5. 1 plus 1 is 2. So our gradient is 5 over 2. And we've got 1 point already here, so now we can try the second equation. Y minus y1 equals m x minus x1. y minus 4 equals m, which is this, negative 5 on 2, x minus negative 1. Negative 5 on 2x plus negative 5 on 2. That's still y minus 4. Y will equal negative 5 on 2x and negative 5 on 2 plus 4, which would be 11 on 2, or 5.5. That would be plus 3 on 2. Not sure where I got that other solution from, 11 on 2. The last question part is down here, and you might like to use the fact that for perpendicular lines, the gradient of one line is equal to negative 1 over the gradient of the other line. Pause the video now to have a go at this problem. Okay, first up we need to find the equation of the straight line passing through 1, 4 and is perpendicular to the line with this equation. So this gradient is equal to negative 1/2. So a perpendicular line is going to be equal to negative 1 over negative 1/2. What's that line doing there? And we can simplify this by flipping the denominator. Those two negatives will cancel and we'll end up with a 2 for our second gradient. So we've got a gradient and 1 point, so we can go straight on to y minus y1 equals m x minus x1, y minus 4 equals 2x minus 1, y minus 4 is 2x minus 2, y equals 2x minus 2 plus 4 plus 2. Thanks for watching the video.